right, so here's a pool.
Here. Okay, so now I draw it a little bit differently, just because I kind of take this pool that you're looking more down on, and I'll take it, just kind of sort of bring it up a little bit. But I mean, that's a decent graphic. Okay, so in our pool here, we have it. I think I'm gonna make this black for now. I'll change things to blue. This one, yeah, this one's 3, right? The deep end is 3 meters. The shallow end is
1.
okay. And how far back does it go?
5.
And how far across does it go?
10.
All right. Now, I typically will say don't put anything on that changes, right? But this is the structure of the pool. So the structure of the pool is not going to change. Now, I'll put some water in the pool. So let's say I'm filling it up, and I'm tempted to make it wavy, but I'll just make it go straight across, okay? So this is my water in here. Now, it's up to you what variables you do want to use, okay? I'm going to use H for height and L for length. But because, that's going to change, right? The higher this water gets, the farther over it's going to go. And that's going to keep happening, right? Until you get to, like, here. And then, still the same thing happens. But at that point, then your length doesn't change anymore. And from there up, like, how far across your water goes is always going to be 10 at that point. But up until then, it's always going to change. Okay. All right, so let's see. Your swimming pool, we use the 10, the 5, the 3, the 1 just to draw the pool. If the water is being pumped into the pool at a rate of 300 liters per minute, okay, so let's write that. D what? What do you think? Huh?
T.
L, maybe?
The reason I don't want to use L's for that, the reason, I know you're saying P for pool. We could use P for pool.
Water. Pump full of water.
Yeah. Nobody's thinking. In physics, what do you measure in liters? Or in chemistry? Or in anything?
Liquids.
Volume.
DT.
Yeah. Yeah. I mean, and you could have used any of those letters. You could. Except for L, only because of the way that I label my picture. Because that's definitely not the L there. Because the L would be changing at linear measurements, and this is liters. Now, this is a hint, right? A note. 1 liter equals 1,000th of a cubic meter. So we can change that later, or we can change it now when you want to change it.
Now,
Okay.
it's your money, use it when you need it.
It's my money and I need it now.
Okay, so you have liters on top. So we have 1 liter. I don't know. I turn everything into.
You're filming from your Mac.
Yes.
That's smart. So it's actually just on there.
Yeah,
You
it'll.
don't
I
have to
know. Why
transfer
didn't I do that in the first place?
You know what?
It's a really good question. I don't know.
I don't know either.
You learn something new every day.
Yeah. I just thought, the iPad's supposed to make your life easier, but it made it much, much, much more difficult.
Yeah.
Sweet.
How's the quality?
I guess the same.
We'll figure it out.
0.3 cubic meters per minute. Right? Right. Okay, so that's my rate of change of volume with respect to time. At what rate is the water level rising?
EW.
Okay, yeah, yours is, right? Because you have W for water. Okay.
H equals 1.5 meters.
And if I don't use H and L, by the way, my joke that's coming up wouldn't work. All right, so we have H's and V's, and we do have to get the volume of the water that's in the pool, right?
Half length, half HL times 5. So 5 halves HL.
Yes. Around here. How you get the volume of any prism, okay, any kind of shape, is you take the area of the base. That's why he said 1/2 times H times L. Because that's, the area of that triangle is half times.
5 is how.
5 is always your width in this problem.
Yes. 5 is how far back it goes.
So that's why I
Okay.
said 5 halves.
Yeah, that's awesome. Yep. All right, so again, your volume is the area of that triangle times how far back that triangle goes, which he said is 5 halves HL. Beautiful. Now, that was actually the hardest part of the problem, really. There is one extra thing to think about, though. Before I differentiate with respect to T,
Units.
yeah, there's going to be units. And right now, if I differentiate with respect to T, there are. And every once in a while, this isn't bad, okay? There is a ladder problem. I'll give you a hint where that's really not bad, okay? But in this one, look at the given information. Can we, right now, do we want to be dealing with all those?
Can't you put in 1.5 for each since you know?
Should you do that yet? No, that'll change derivatives. If you put in numbers too early, that'll change derivatives. Okay, that'll change the behavior of the whole function. So since the h, since the height's not a constant, you can't do that. But I mean, here's my question. Not even how to deal with it, but what don't you want in this equation? The length, right? So you have to get the L out of there. That's my joke.
Punchline.
That's not how to use it out. Okay, do you guys want to take a break?
Okay,
This
we're
is like
getting the L
floating
out
stuff
of there.
Yeah, we're getting that. We left off with we got to get the L out of there. How would I get rid of the L? I'll give you a hint in a minute on the picture if you want it.
Like we want to completely eliminate it.
Yes, we want to eliminate it from here, not by erasing it, but by making some type of substitution, which someone alluded to earlier.
Is it going to be in terms of H?
Yes.
Is it like a ratio?
Huh?
Like a ratio?
Like what?
A proportion. Like 10 over L is equal to 2 over H.
Oh, we have to do that in college. Do you remember this?
Wow.
Would that help?
Did we?
Yeah.
Well, I think I stabbed my computer after doing that.
Well, look at that.
Shut up.
How
Wow,
about them
that was
apples?
Shut up. That is.
On that tree, they cast a shadow, and there was somebody. Yeah.
Yeah. You determine the height of the tree because you measured yourself in the shadow. So.
Yes, don't you remember that?
Yes, those were all the VSSAs.
Yeah, but that was like.
Yeah, but that was
First
easy
grade.
stuff.
Like I think I came out of the room and I was doing shadow casting.
Why do we know
problems.
that's 2?
Why do what?
How do we know that's 2 up there? The side is 2.
Because the
3
because-
minus 1.
Because there's one
the
meter
one
over
block
here and
there.
it's perpendicular, so
Okay.
Subtracting it.
okay. All right. So finally, we have volume as a function of one variable, just the height,
wow.
and it's all easy from there, right? And then we'll start to bring in the units. So now we have dV, dt. All right, so let's plug in the units. Oh, actually, what should we solve for first?
DH.
See, Mr. Haladia, we do that for you.
What?
Before we start plugging in our givens, just willy-nilly, wherever they go,
Yeah,
we solve for the quantity that we're looking for first. For you.
I love that.
Because I never used to do that
Really?
until I realized it was your pet peeve. One of,
Why write all those units all the time? Well, because math people don't use units, so they don't.
no, we
Yeah,
most certainly do.
Well,
That is my slow for the year. My student learning objective.
Yeah,
We're going to
it
have them
doesn't
do stuff
happen.
without units and then with
It
units and
doesn't
see how
happen
much
in
the
the other
units help them.
classes. If there was unit recognition all the way through school, students would do so much better
Oh, yeah.
in classes.
I do better on practice AP exams when I use units.
See?
right? Because then you know when to integrate. You remember if it's an average value problem and you have to divide by something. You know when to differentiate. All right.
Try telling that to the department.
It's a fake.
Remember, we're recording, so I'm just gonna.
Okay.
I'm just gonna finish my
No
problem
comment on Mrs. Hapich's plan.
This is going on my wiki.
Hi Marissa, how's the band trip?
Yeah, just exclude Bobby and Veronica, because they're not on the band trip.
Now, I'm going to leave a little space after the 25, and you're going to tell me why in a minute.
Isn't Bobby just helping somebody with it?
25 has a unit of meters.
Very good. 25 has a unit of
Because
meters.
the 5 from the volume equation has a unit of meters. That we didn't do.
Yes. Right there. I'm just so happy. Yeah. So this 5 had a meters with
It's
it,
all coming from this side of the room. Just
which takes you to the. Looks
It's
like your mistletoe date's gonna pop you in the face pretty soon.
Please report to the guy's office. Thank you.
If this class was like 4th period or like 9th period, I'd be fine.
You guys realize those are all just flow rates you're doing up there? You're filling a pool and
Do you know, Brittany and I are doing, we just got done with physics. We were doing work involved to pump water out of a,
I need to take calculus again.
I need to understand physics.
You just need to sleep.
Did you read my research paper yet?
No, I didn't. No, I do have to now. Yesterday was just
What is it?
crazy.
Superconductors.
And I believe this is, if anyone wants to verify,
Now we're good.
0.008.
You know, the physics is easy.
That is not seen.
We're doing electric fields and the physics is over in like 2 minutes and then it's
Uh-huh.
all mappy.
Yeah.
Are they working on stuff? Look at this.
Any questions on this? Going once, going twice.
I need to make sure I got the.
What did we just
Okay.
go over? How fast the height of the water changes.
Mhm.
So
And you
now
guys
let's find
tell
the
me,
length of the water.
you could,
Function.
if you wanna, whatever floats your boat. So, when would the water level be changing quicker?
At the bottom.
At the bottom.
Mm-hmm. Yeah, because you got, right, you get it. So, again, to summarize, so related rates, right? One rate is constant, the other rate typically is changing. Typically. Every once in a while, you're going to notice that it doesn't matter. But let me tell you, you're going to have a pool problem, a cone problem, a sphere, usually a cube, a shadow, a ladder. A ladder's coming down a wall. And then similar triangles are out the window, right? So,
Oh, yeah.
because they're not similar anymore. So you'll do some other stuff.
Similar
And-
agencies.
And a boat, and a revolving light, and I'm just and planes, airplanes flying towards each other or away from each other, or cars. Okay. Yeah, but that is like the revolving light. So this is what I'm saying. Once you do one of everything that I just said, every other stuff is like it. Okay? You're going to get it if you've already done the revolving light problem and then you get the train problem, you're watching a train problem, it's going to be the same.
You did a good job as a teacher.
You guys do
If
a
you
good
did.
job of, yeah. Want to see it?
What is PPS?
PPS is practice problem solving. So I have to get you a. Why can't you see it? There we go. So these are the problems out of the book, and I have to run you guys off problems off of a worksheet.
Don't worry about it.
The book is in Miss Carlisle's
Take your
system.
time.
So
Forget about it.
forget about it.
Sleep on.
Okay. Somebody gonna start singing that?
Singing what?
He said sleep on it. You don't want to sing?
Oh, I
Isn't that Meatloaf? Let me sleep
don't know.
on it. Baby, baby, let me sleep on it.
Oh,
Huh?
yeah.
Okay.